Alright guys, welcome back to my channel again. You're welcome to Master Builders Online Academy. In this video, I'll be showing you again how to rightly apply first law of engineering thermodynamics to solve problems on thermodynamics. Remember, in our last video, we actually talked about the first law of engineering thermodynamics. So if you have not watched that video, ensure you go back to our playlist and make sure you watch that video first before watching this, because there are basic conditions that we actually give over there. There are principles that we released to help you solve problems here. So understand that without principles, you may not be able to solve problems effectively. So this is one of the reasons why these problems are to be solved using those principles. So very quickly, without further ado, let's quickly examine the question that we have before us and provide the necessary solution. Don't forget, we are problem solver. Now, the question before us is, if the heater adds 550 kilojoule of heat to the system, add this to the system, and the cooler extracts 290 kilojoule of heat from it. I hope you can see it. Determine the work done at the turbine or compressor shaft. Determine the work done at the turbine or the compressor shaft. Now remember that here we are only dealing with heat, as you can see. So the work done we are actually asked to look for now is the summation of the heat, as long as heat are the only thing mentioned as far as this question is concerned. We have heat added and then we have heat extracted. So one of the things is that in applying those principles before, we need to define the parameters that are given according to the basic signs that we claim will be attached to these values. So let's dive into this. Now, as you can see, the first thing that we have is heat added. Heat added. Okay, let's call this HA, or we can call it QA. Okay, and then QA is given to us as 550 kilojoule. But don't forget that when a system receives heat, when a system accepts heat, it is positive. So this heat is positive because it was added to the system. Now again, we have heat extracted. Okay, let's call this HE, which is extract, or QE. And then the value for this is 290 kilojoule. Can you see, guys? So now, as you can see now, there is nothing like work done. So we are not actually using the first law of engineering thermodynamics. We are using the summation of heat. But first, understand that whenever a heat is extracted from a system, it means that the system lost. It means that the system rejects. It means that it was removed from the system. And whenever heat is removed from the system or extracted from the system, such heat is taken as negative. So we have this as negative. I hope you are following me. All right, so haven't gotten these parameters, then all we just need to do now is to get the work done as stated. So understand that summation of work done in a system is always equal to summation of what? Heat in that system. Are you there? Is equal to the summation of heat in that system, which is what? In a cyclic process. It shows that, and then we understand that this heat is equivalent to the sum of these two heats, which is HA plus HE, or otherwise you can say that this is QA plus QE. Remember that these are two heats, summation of all the heats. So now, haven't gotten this is the algebraic sum. Remember that we already have the value for QA and then we have value for QE. All we just need to do is to put in the value. The value for QA, guys, as you can see now, it's 550 kilojoule. then plus. The value for QE is minus 290 kilojoule. Are you there? So by the time we remove this bracket, we have 550 minus 290. Hope you can see this, guys. When you remove 290 from 550, we have our outcome as 260 kilojoule. This is the answer to this question. Then we have, therefore, the cyclic sum of work done is equal to the cyclic sum of what? Heat, and both is equal to 260 kilojoule. So this is the answer to this very question. So as you can see, it is actually very, very simple to solve. All you just need to do is to understand the basic principles that works. I hope you understand this question very, very well. If you do, please don't forget to like this video, share this video, and leave a comment at the comment section. Meanwhile, if you are yet to subscribe to this channel, do please consider subscribing to this channel and then turn on the post notification bell so that whenever we upload mind-blowing content, you will be notified. Without further ado, let's jump into next question. All right, guys, welcome back again. We have another question before us. Okay, now the question goes this way. In a compression stroke, in a compression stroke, remember what is happening in the compression stroke? Okay, the heat rejected, when the system is compressed, it means that you are actually trying to remove some things, they must be lost. Okay, so, but first, in a compression stroke, the heat rejected to a cooling water. You see now, so when the water is cooled, maybe you boil the water, for instance. Now, after boiling the water, maybe you want to use it to make a tea, and then leave it for like 1, 2, 3, 4, 5 minutes to 10 minutes. Before you come, you will find out that the degree of hotness, which is temperature, has actually reduced, right? So because it reduced, that means heat has been lost, heat has been rejected, heat has been extracted from the initial water that was maybe heat to 100% degrees. Hope you understand it. Okay, so the heat rejected to the cooling water is 62 kilojoule. As you can see now, is 62 kilojoule per kilogram. And then the work input is 120 kilojoule per kilogram. Full stop. Now, we are asked to calculate the change in internal energy. Calculate the change in internal energy. Calculate the change in internal energy. So you can see it on red now. This is what we are asked to calculate. Calculate the change in internal energy of the working fluid, after which state whether it is a heat, it is gained or lost. Calculate the change in internal energy of the working fluid, stating whether it is a gain or lost. Before you can get to this other level, you must ensure that you have done run you through your calculation. So first thing we want to do here, because this is a word problem, is to extract the given parameter. So we'll start by given. Okay, so the first thing that we have now is heat, Q, and it's giving us what? 62 kilojoule per kilogram. And then as we read through, we also have the work input, which is work done, W, and is given as 120 kilojoule per kilogram. Okay, so as you can see from what we have here now, we are now asked to find the change in internal energy. Change in internal energy. And you know that this change in internal energy is given as this. This is what we are looking for, as you can see. So all you just need to do now is to check out in your dictionary where you store your equations and see the particular equation that connects these parameters here. So you find out that from this question, nobody stated that this question is from first law of thermodynamics, but having extracted the given parameters here, we find out that we can actually use the first law of engineering thermodynamics to solve this. But the first thing we need to do now is that we need to recall that change Recall that Q minus W is equal to change in internal energy, or change in internal energy is equal to Q minus W. Now, before we put in the values, let me bring you back to this question again. From the question, there we have 4 laws that we stated earlier, 4 keynotes in first video. So if you have not watched that video, make sure you go and watch that video. We stated that when heat is rejected by the system, remember that it is the compression stroke now that rejects this heat, or this heat is lost because the water experiences cooling. So because heat is lost, heat is rejected, it means that this heat will be taken as negative. Don't forget, this is a principle. So as you can see now, the value never came with negative, but because of this word that precedes it, you see that we are taking this guy as negative. All right, now when we come down to that of work done, we find out that this is work input. Work input. Work input means this is the work done on the system. Work done on the system. Work done on the system. Work input. Work output is the work done by the system, but work input is the work done on the system. That means this work also is negative. Work done on the system, not work done by the system. Work done by the system is output, but work done on the system is input. I hope you understand this. So we can come to this level now and then have that Q is negative 62 minus our work done is negative 120. And then when we simplify it, this is negative 62 minus multiplied by minus will give us plus 120. And then minus 62 plus 120, that would have given us 58 positive. Okay, we have this as positive 58 kilojoule per kilogram. This is the change in internal energy. This is the change in internal energy. Of course, you can extend it by change in internal energy, which is U2 minus U1, all is equal to plus 58 kilojoule per kilogram. This is it. So now, if you are now asked, from the question, when you check the question, you're now asked to state whether it is gained or lost. Remember that the internal energy is gained when it is positive and it is lost when it is negative. Hope you understand the condition. So therefore, because the value we have here now is positive, it shows that it is gained. I hope you understand this. So it is a gain in internal energy. Are you there? Internal energy. So this becomes 58 kilojoule per kilogram. All right. Now, so now that we have been able to do this, we have successfully answered this question. Why is it gain again? It is gain because the outcome is positive, and if it is negative, it means it is lost. I hope you understand this very, very clearly. So this is the question. We have been able to provide the required answer to this question. So without further ado, we are diving into the next question, still using this same equation. So let's quickly dive into that. All right, guys, now we have another question before us again. Remember, we are still solving problems, and then we are in the business of solving problems. Now we have before us, in an expansion stroke, the heat absorbed to the heating water is this. That means this water is to be heated, and then the heat received by this water is 90 kilojoule per kilogram. And then the work done by the system is 140 kilojoule per kilogram. Now the question demands that we calculate the change in internal energy of the working fluid and then stating whether it is gained or lost. Hope you understand the question. So the first thing we're going to do again, because this is a word problem, is to extract the given parameters, which include the known and the unknown. What this will help us to do is to help us trace the formula that connects the known to the unknown. I hope you get that clear. Okay, so let's begin with this. So given that, all right, so we are given heat, as you can see now, Q as 90 kilojoule per kilogram. So without further ado, let's just check what type of heat is it. Heat accepted, heat rejected, heat absorbed, or heat involved? Heat absorbed. Heat absorbed means heat received, heat accepted. So because it is accepted, this heat will take it as positive. Heat accepted. Now, this is it. Then we have work done. Now again, the work done is 140 kilojoule per kilogram. And what happened? Is the work done by the system or the work is done on the system? As you can see, this work is done by the system. And whenever work is done by the system, such work is taken as positive. I hope you can see it now. Work done by the system is positive and work done on the system is negative. So we are taking this as positive because the work was done by the system. And then what are we looking for? Change in internal energy. Change, okay, in internal energy. And that is this symbol. It's unknown. So now that we have, these are the three parameters that we have as far as this question is concerned. So all we just need to do now is to find a way to bring in a relationship that connects these three variables. Are you there, guys? And what's this equation? Is the first law, equation from the first law of thermodynamics, and that equation is Q minus W, which is work done, is equal to change in internal energy. And then because we are looking for change in internal energy, you can simply just make change in internal energy the solid formula, and then we have this as Q minus work done. All right, so all we just need to do now is to substitute. The Q, which is the heat, is 90. Then minus the work done is 140, positive. So now 90 minus 140, we'll have this as minus 50 kilojoule per kilogram. I hope you can see it. So it shows that the change in internal energy, therefore, change in internal energy, which is the same thing as U2 minus U1, is equal to minus 50 kilojoule per kilogram. This is the value. But now this is not all to this question. All right, so when we look at the question, we were also asked to state whether the fluid gains heat or lost this internal energy. So is this internal energy gained or lost? As we can see now, because the value we have here is negative, that means the internal energy is lost. So we can therefore state now that it is lost. It is a lost in internal energy. And that value is minus 50 kilojoule per kilogram. So guys, this is all about this question. So you just find out that these problems are very, very simple, very, very easy to solve. All you just need to do is to extract the given parameters, get an equation that connects the parameters, and then you are good to go. I hope you have actually learned massively from this particular question. So guys, please don't forget to like this video, don't forget to share this video, and don't forget to leave a comment at the comment section. Please, if you are yet to subscribe to this channel, kindly subscribe to this channel. This is the only way you can actually encourage us to keep doing more and then keep uploading mind-blowing content like this. And as well, if you don't want to miss out of our mind-blowing content like you see here, do ensure you like, subscribe to this channel so that you can be eligible to turn on the post notification bell so that whenever we upload mind-blowing content, you will be notified even while you are at sleep. So without further ado, guys, let's just jump into the next question as we begin to solve more problems in this course. All right. Okay, guys, now you're welcome to another section with me. Now, as you can see, we have another question before us. This is Master Builders Online Academy, and as such, we are in for solving problems. So now let's look at this question. A gas, listen, you must understand these questions very well to be able to provide solutions to them. The question may be very long, but the answer may be very short. Okay, so a gas is compressed in a cylinder. This is a system. Now, cylinder is a system by a movable piston to a volume 1/2 its original volume. 1/2 its original volume. 1/2 its original volume. Full stop. During this process, it was found that 320 kilojoule of heat left the gas, and the internal energy of the gas remains the same, considering the gas at the system. Now we are asked to calculate the work done. I hope you can see it here. This is it. Let me just quickly put it, change the color. This is what we have. Calculate the work done. Calculate the work done. So how do we calculate the work done? It's still the same thing, guys. All we just need to do is to extract the given parameters. After extracting the given parameters, we find the relationship that connects the known and the unknown parameters. It's as simple as this, guys. Very simple and as simple as this. So now let's get that done. Given, what are we given? Now, if you can see now, we are given heat. Check it very well. Heat. And the heat is giving us 320 kilojoule. But if you read this very well, you will find that it was found that 320 kilojoule of heat left the gas. That means rejected. That means lost. Are you there? That means what? Involved. That means subtracted. And then whenever heat is lost by the system, that heat is taken as negative. I hope you understand why this negative is coming in now. Because it left the gas and then the gas lost it. Then as we read further, we were also given that volume. Okay, V1. We don't know the value, so we call it S. Then V2. So we're told that V2 is half of the initial volume, such that the volume become half of the original. Okay, so that means 1/2 V1, and this is same thing as what? 1/2x, or you can put it as 0.5x. This is volume 2. All right, so what other parameters are given again? We were told that the internal energy remains constant. Now, whenever internal energy remains the same, that means the internal energy is 0. Otherwise, let's do it this way. Now, internal energy. Internal energies. Okay, now U1 is equal to U, and then U2 is also equal to U. This is what it means to be constant. So now what do we need to do? We just need to recall that change in internal energy is equal to U2 minus U1, which is U minus U. And then change in internal energy is equal to 0. Now, whether you do this, I just use this aspect to show you what I have here now from U1 equals to U, U2 equals to U, and then change in U is equals to U2 minus U1, and both equals to U minus U, and then we have 0. It's just to show you how we arrive here. But just understand that anytime you have a statement like this, internal energy of the gas remains constant or remains the same, it means that there is no change in internal energy. And anytime there is no change in internal energy, the internal energy is always taken as 0. Now, again, when we look at the question, what are we asked to find? We are asked to calculate the work done. So let's put down work here. Work done. That's W. Now, as we can see now, the work done here is given as unknown. So, looking at this question, I have heat given, I have internal energy given, I have work done. That means I don't even need these volumes here. I don't need volume. Remember, if you check the first video we uploaded on this when we're solving for work done, you only calculate for work done when using volume when you are given pressure, right? So we then said that, as you can see on the screen now, that work done here is pressure multiplied by change in volume, and then we now see pressure is equal to V2 minus V1. I hope you can still remember this that I have here. So this is when you use volume. So because we do not have pressure here now, there will not be need for us to make use of volume. So those volumes are just given, but they will be useless as far as calculating for work done is concerned. So as far as I have heat here and I have change in internal energy and then I'm looking for work done, I can just go ahead and apply the first law equation for thermodynamics. Are you there? So now let's take that equation. All you need to do, guys, is to still recall that Q minus W is equal to change in internal energy. I can decide to make W the cellular formula because that's what I'm looking for. So if I do that, W would have given us Q minus change in internal energy. I will just take this guy to the left end and then take the other to the right end. I hope you understand it, how to make a particular variable the cellular formula. Now, what is the work heat? If you move up here, you will find out that the heat that we're given was heat rejected, right? Which is negative 220. So we put down the value here, negative 320. Then minus internal energy, as you can see here, is 0 as long as it remains the same. Then we have this as 0. So work done here become minus 320 kilojoule. This is what we have. This is the work done, my people. It's as simple as this. It's as simple as it. So this, on this note, take for instance, we are now asked what type of work is done. What type of work is this? Is this work done by the system or work done on the system? Please help me check it out. Please help me check it out. Check it out. This work, is it a work done by the system or work done on the system? So I'll quickly remind you the condition. Remember that work done by the system is positive and then work done on the system is negative. So because this value is negative, it shows that this work was done on the system but not by the system. Therefore, work done on the system. I hope you understand this condition. So this work is done on the system, not by the system. Done on the system and not by the system. I hope I have been able to help you as promised, hold you by hand, and then teach you all the things that you really need to know in applying the first law of engineering thermodynamics to solve basic problems. Thank you guys for watching. So if you are yet to subscribe to this channel, do consider subscribing to our channel and then turn on the post notification bell for more exciting videos, because very soon we'll be diving into another part of this, which will become part 3 or part 4 as the case may be. But just ensure that you check the description of this video so you can find the link to the next video. Love you guys. Thank you for watching. Thank you. Don't forget to share, don't forget to like, and don't forget to leave a comment below. Tell us what you can see and what you can say about this particular content. We love you guys. Thank you. See you guys in the very next class.